Because everything is not working today and we really need to practice and go over counting these atoms. Alright, because I'm not loving what I see on that little quiz y'all guys did today. So, here are some formulas, and I even have 2 equations down here. And we're going to sit here and work through some of these. Alright, so before we even start, I want to go back over some of the stuff we talked about on the Zoom today and I did in the videos. We have coefficients, all right? The coefficients are going to be these big numbers. It's labeled right there. You have access to this paper. Please start looking at it and using it. We then have the subscripts, okay? Those are the smaller numbers down here. The coefficients tell us the number of molecules in which we have of this formula. So this 4 right here tells me that we have 4 molecules of this glucose. This subscript tells me the number of atoms of that specific element that it is in behind. It tells me how many atoms of that. So this 6 tells me in one glucose molecule, I have 6 carbon atoms every single time. All right. Now, if I have 4 molecules of glucose, I'm going to do the 4, which is the coefficient, times the 6, which is the subscript. And that will be in 4 molecules of glucose. I have 24 atoms because it's 6 times 4, right? If I got to have 6 every molecule, then if I have 4 molecules, 6 times 4 equals 24. So that's how we solve for these atom amounts, all right? So up here at the top, I want everybody to write step 1. So step 1, when we are counting atoms, we need to identify the elements. All right, so we're going to go ahead and do that here. So what are our elements and how do we identify them? All right, so hopefully you know by now when we identify elements, we count capital letters. All right, so if we're going to count capital letters in this one, I have a capital H, right? I have a capital S, and I have a capital O. So hydrogen, sulfur, and oxygen. All right, now step 2. Is there a coefficient? Because if there is, what are we going to do? If so, we multiply. Okay, so on this first one right here, we don't have a coefficient. All right, so since there is no coefficient there, it's kind of like a 1. If you always want to think of it as like a 1, if there's nothing there, that works. All right, so there's no coefficient. We can still multiply, but if whatever we multiply, 1 by 2 is going to equal that 2, right? So if I'm looking at my first one, oxygen, 1 times 2 is obviously just 2. Sulfur, there's no number behind it, so it has no subscript. So what is its subscript? There is no number. We imagine there being a 1 there. So if we wanted to imagine that 1 times 1, we have 1 sulfur. Okay, then the oxygen, it has a subscript of 4, so 1 times 4 would be 4. All right, so our total atom amounts would be 4 plus 1 is 5 plus 2 is 7. So 7 is our total. Oops, I probably should go up here. Step 3. We found the atom amounts per element. Step 4. Add total atoms together. for a total amount. All right. So now, looking at number 2, what's step 1? We identify the elements. How do we do that? We count capital letters. So I have a capital C. So I know that CA is 1. And then I have a capital C and a lowercase l. So I know that CL is also 1. Now, step 2, is there a coefficient? No, there is not. There is no number there. So that means I just have one molecule of this. So Ca, calcium, has no subscript either. So it'd be 1 times 1 essentially is 1. Chlorine has a subscript of 2 and no coefficient. So that would be 1 times 2 essentially, which would be 2. Then step 4, add the total of atoms together. We have 2 plus 1 is 3 in total. All right, go down to number 3. I'm going to give you a minute. Step 1 is identify the elements. So identify the elements by counting the capital letters. All right, so what are my capital letters here? I have a capital F, right? So Fe is going to be an element, which I believe is iron. Iron is something weird. I think it's Fe. And then I have a capital O, which hopefully we know by now is oxygen. Do I have a coefficient? That's step 2. So remember, coefficients are the big numbers out in front. So there is no coefficient here. So this is iron, because I think this is actually rust. This is what the molecular formation of rust. So Fe has a 2 subscript. All right, so no coefficient. So we're going to have 2 iron atoms. Oxygen has a subscript of 3 with no coefficient. So we are going to have 3 oxygen atoms. When we add all of those together, we are going to have 5 in total. Now I'm going to skip down. I'm going to do number 5 with you. All right, and I will do, I think, 5 and 6. I'll do those with you, and then I'll do 9, and then you're going to finish this worksheet on your own. All right, so hopefully you've been writing this down. I don't know if I said that at the beginning, but I'll make sure I put it in the notes. All right, so down on number 5 now. So what's our first step? We identify the elements, right? How do we identify the elements? We look for capital letters. So what are my capital letters here? I have an H, which is hydrogen, and then I also have an O, that's for oxygen. Do I have a coefficient? Remember, a coefficient is the big number out front. So do I have a coefficient in this one? Yes, I do. What is my coefficient? The big number out front. It is a 2. So what do we do with the coefficient? We multiply it with the subscript. All right? So on this one right here, let's solve for hydrogen, this first one. Okay, so what is the coefficient of hydrogen? It's 2. What is its subscript? It's also 2. So we would do 2 times 2, which would be 4. So in 2 molecules of this H2O2, I have 4 atoms of hydrogen. All right, now do oxygen. So oxygen, what's its coefficient? This big number out front, so its coefficient is 2. What's its subscript? It's also 2. So 2 times 2 is 4. I total all those up, and I have 8 in total. All right, number 6, we'll do 6. So first thing we do, identify our elements. How do we identify elements? By looking for capital letters. So what are my capital letters here? I have C, which is carbon, and I have H, which is hydrogen. All right, next step, do I have a coefficient? Remember, coefficient is the big number in the front. So, do I have a coefficient? Yes, I do. What is my coefficient? It's 4. All right, so whenever I'm solving for carbon, C, what do I do with my coefficients? I multiply it by the subscript. So 4 times 6 is going to be 24. So I have 24 carbon atoms in 4 molecules of this C6H12. Then I go to hydrogen. Look at hydrogen. It also has a subscript of 6. So what do I do with the subscript and the coefficient? I multiply. 4 times 6 is, again, 24. So I have 24 carbon atoms in 4 molecules and 24 hydrogen atoms in 4 molecules, and I add those together and I get 48 atoms total. All right. I'm not going to do this one with you, but remember, these parentheses, that subscript goes to everything within that parentheses. So that 4 is going to go to that Si, and it's going to go to that O, that oxygen. All right, now down here, told you guys that you would have to be looking at atoms and figuring out if, or not atoms, you would be looking at equations and figuring out if they are balanced or not. Okay, so just like anything else, we need to figure out, we know that this is our reactant side, and this is our arrow, and this is our product side. Wrap, right? Like the sheet that you guys got today or Monday. So now, if we are going to see if this is balanced, we have to essentially do the same thing. We got to figure out what elements we have on either side. Then we got to figure out how many of those elements we have. All right, so over here, how do we identify elements? We look for capital letters, right? So I have a capital C, I have a capital H, and then I have a capital C with a lowercase l. All right, over here, I have a capital C. I have a capital CL. I'm going to write it down here so it's in line. And then I have a capital H. I have another capital CL, but that goes with that, right? So over here, for carbon, do I have a coefficient in front of it? No, I do not. So it's like there's 1. Do I have a subscript behind it? No, I do not. So it's like a 1. So how many carbons do I have here? Just 1. Then hydrogen is the next one I'm solving for. No coefficient, subscript of 4. 4 times 1 would be 4. Chlorine, no coefficient in front of it, but it does have a subscript, so 2 times 1 would be 2. Now, carbon, our first one, we have this 1 carbon, no coefficient, no subscript, carbon's 1. They balance out. Now let's look at our Cl. In this one, no subscript, no coefficient, so we have 1 Cl over here. So we put 1 over here. And we have no coefficient, no subscript, 1 Cl over here. So altogether on this product side, we have 2 Cls. So that balances out as well. Now, if we look at our H, which is the last thing we need to solve for, no coefficient, no subscript, we only have 1. Now, do all these numbers equal those numbers? Is this a balanced equation? 1 carbon, 1 carbon. 4 hydrogens, 1 hydrogen. That's not balanced, right? So I have too many hydrogens on this side. So this is going to be unbalanced, which essentially means not equal. Okay, now on this one, you are going to work this one out yourself. So remember, if you forget what you do, step 1, then do step 2, then step 3, and step 4. All right, you have to do it on both sides. So you've got to figure out your elements on this side, total each element up, add them all together. Well, you don't have to add them all together, but you're going to total them up. Then figure out your elements on this side, then total each one up, and then you're going to compare and then tell me, is it balanced, unbalanced, equal, or not equal? All right, and you still need to do 4 and 7 and 8 up here. All right, when you get done with this, I want you to take a picture of it, and you will submit it on whatever assignment that I submit this to. I haven't made it yet because I'm just now making the video, but this will be an assignment. This will be practice. I need to know that you guys are getting this, because if not, we are going to keep doing practice after practice after practice after practice of this. Remember, everything in the universe is made out of these atoms and made up of these molecules, so I can get as many examples as I need. So please watch this video. If you have any questions, let me know. I need to know how to help you guys. All right?